All right, welcome. Thank you. So the project here, repair and restoration of the westbound Bay Bridge, US 50 and 301 deck rehabilitation. The owner was the MDTA, engineer was Wallace Montgomery and Associates. I work with Wagman Heavy Civil, which was the general contractor. So we were placing latex-modified concrete, which we produce and place on site. Cement was from CTS, admixtures from GCP, Grazio St. Gobain, aggregates from Cheney and SW Barrick, and this award was submitted by Wagman. So project background, this is a high-profile, high-traffic volume project carrying 45,000 vehicles daily in each direction in the summer. So the attempt was to reduce impacts. There was a incentive-based schedule that basically had the contractor trying to place the latex-modified concrete over 2 seasons. When Wagman bid the project, we did not have that in our bid. We did not plan to do that. We kind of viewed it as not very possible. So we're replacing the existing bridge deck surface with latex-modified concrete. This would be the right-hand lane westbound at this facility. They refer to it as lane 1, which is pretty confusing for most contractors. So there was a prior overlay on the bridge deck that consisted of an existing microsilica fume overlay. And there were other prior projects that included removal of this existing overlay. So the attempt was to remove all of the existing microsilica. On top of the latex modified concrete, we're replacing the existing expansion joints while coordinating with multiple ongoing contracts. And there were also upgrades to the intelligent transportation systems. So the existing conditions, again, the microsilica overlay remained in the rightmost lane from 2004. So lane 1 had a lot of heavy patching and deteriorating conditions. So nightly, maintenance contracts were going out and performing patching in the lane 1. As you can see in the picture, it kind of begins to look like a quilt out there with all of the patches over time. So you can see the bridge, westbound Bay Bridge opened in 1973, and then between 2000 and 2004 there were partial deck replacements, and that's where the microsilica overlay comes into play. In 2004 and 2005 they replaced lanes 2 and 3 or portions of lanes 2 and 3 with latex modified concrete. In 2007 and 2010, they replaced the deck and suspension through truss spans, about 21%. And then this project came into play in 2019. So between 2019 and 2022 was really when we were placing the latex for this project. Let's see here. Yep. So in 2000 and 2004, the westbound lanes were overlaid with the microsilica, but they caused immediate issues. I believe they were delaminating was my understanding. So Wagman was brought in 2004 and 2005 because the issues with the microsilica was deemed an emergency repair. So we had done this project previously just in different lanes, so we had good knowledge of the project. When the contract came out for lane 1, obviously we had gone after it. So lane 1 had about 50% of the deck area patched or delaminated until it was replaced under this project. So the latex modified concrete was the end product that we would be placing, but we had to remove all of the existing surface, and then below that surface was where the microsilica was. So we were doing mechanical milling and hydro demolition to remove all of the existing overlay so the new latex could bond to the original substrate. So why did they choose latex modified concrete? So for the MDTA choosing this, this is a tested material technology since the 70s. I think Wagman Heavy Civil has been placing it sometime in the early 70s, so they were very up on this and new with it. There's extensive use in Maryland and the Mid-Atlantic. Virginia, VDOT uses this a lot as well. The bond strength exceeds the based concrete strength. There's low permeability and chloride penetration. A low modulus or elasticity, flexible, and provides extended service life. So there's proven performance at this particular MDTA facility in lanes 2 and 3 that there have not been any known issues since 2005. So the project requirements was complete removal of the existing overlay, all spans except those previously replaced under prior contracts. The latex-modified concrete in lane 1 was about 12,350 feet long, 12 foot, 12 and a half foot wide. The contract documents had the overlay being at 2 inches. Our average depth of placement at the end of the day was 3.5 inches, which is somewhat interesting. As I get a little farther into this presentation, you'll see some more of the existing conditions. Again, there was a lot of localized deck patching that was required to maintain all the lanes during this project. We replaced 22 expansion joints throughout the project as part of the many spans within the bridge. After completion of the latex-modified concrete, we placed a silane sealant to all lanes of the bridge. Maintenance of traffic was huge, lots of nightly closures of the bridge to go out and complete our work. We also had replacement of the overhead gantries, which include the lane use signals. That was part of the ITS upgrades on this project. We also had some CCTV cameras to replace, and the bridge rail posts that you can see on both sides here. We had like 200 posts to replace as part of this project as well. So here you can see the, well, looks like I lost one of them, but there's 4 work areas, 4, 3, 2 would be right here, and work area 1. So the 12,500 linear foot of latex modified concrete in lane 1 is comprised of these 4 work areas. 4 and 3 being the 2 largest areas, work zone 1 and 2, the 2 smaller ones. So again, we did not plan to complete all of the work in one season because we didn't think it was possible. So our original plan was to tackle one large work area, and one of the smaller ones. So season 1 or year 1, a large one and a small one. Season 2, a large one and a small one. So that would get you to about close to half of the linear footage for lane 1. So again, this was bid back in 2019. Our plan was to do it in 2 construction seasons, so that would be in the fall of 2019 and then again in the fall of 2020. As you can see, the bridge has 3 lanes here, so we were working in lane 1 here. The difficulty for performing this work is that you almost always needed a second lane to place the latex with the trucks, to service any of the equipment. So lane closures were extensive. We did predominantly all of our work at nighttime under full bridge closures. On the schedule, the contract requirement said that we could only place latex between May 1st and November 30th, but we were not allowed to have any long-term lane closures, which would be our barrier wall defining our work area or protecting our work area. So we couldn't do that between October 1st and April 15th. So it really reduced your construction season or window, and a lot of that was driven by traffic traveling to the Eastern Shore, going to Ocean City. a lot of events late summer, early fall. You know, reducing the lanes down would cause a lot of backups. They couldn't run contraflow traffic, so a lot of the changes on this project were directly related to traffic impacts and implications to the traveling public by placing this barrier wall out there. So Wagman was eventually directed to accelerate the schedule by combining and condensing the schedule to complete all the latex during one construction season. All construction activities were scheduled during nightly full bridge closures, and we did have some daytime lane closures that we were permitted, but they're rather short, about 4 hours or less. So here you can see this is kind of the original plan, to have 1.5 inches of mechanical milling, a 1/2 inch of hydro demolition, and then this would be any localized hand removal. This was really kind of the intent was to, again, get all of the existing microsilica overlay. So for the demolition process or the deck removal process, you want to maximize the mechanical milling depth. As far as speed, time, schedule, your milling is going to be your fastest. Your hydro demolition would be your second fastest, and your slowest would be your localized hand removal, which is just large teams of guys and jackhammers just going at it. So we're really trying to reduce as much of that as possible. So you can see that we have 1.5 inches, 1/2 inch. You should be right around 2 inches plus or minus. Again, our average depth of placement for the entire project was 3.5 inches. So when you're talking about an increased schedule, you know, trying to reduce the hand removal, we obviously were trying to go as deep as we possibly could with the mechanical milling and the hydro demolition. So 1 to 1.5 inches for mechanical milling, and 1/2 inch to 1 inch of hydro. 1.5 to 2.5 inches was the overall intent, but we ended up at that 3.5 inch average. So it was advantageous for us to scarify as deep as we possibly could without damaging the rebar, since you know, that is the fastest process of the three to increase our time or our schedule. The hydro demolition, so it was only supposed to be a 1/2 inch, ended up being right around 1 inch. So this is somewhat tricky because you are taking this very high, more or less a pressure washer, but much more sophisticated than that. So here's a picture of the robot. It has a high pressure jet of water that's going back and forth over the concrete. You do a test pass and you get a, you know, this was kind of the texture that we were going after. This is what we wanted the deck to look like, but because the deteriorating deck had different patches, you would go from this quilt of patches to, you know, sound concrete. 6 inches later, it would be a deteriorated patch. So you're setting up this robot to do this high pressure demo, and you have it dialed into the proper pressure. It's going along great, everything's fine. 6 inches later, you're blowing a hole straight through the deck. So it required constant monitoring. You know, we weren't trying to have any blowouts where you would see the bay below, but it obviously happens. It was just one of the challenges of this project. So the hand removal, which we were trying to eliminate, we obviously did a pile of it. So you can see some of these gangs of guys that we would have hand chipping to remove all of the existing overlay. But we kind of had an assembly line of scarification, hydro demolition going on at different points within the project, followed behind with you know, teams of guys doing the you know, hand removal. And then in other locations that were already had the demo completed, we would be pressure washing, cleaning the deck, prepping it to be placed, and then in other locations we would be actively placing. So I think at our peak on this project, we had about 100 guys out there, which, you know, probably is nothing compared to the Nice Bridge, but trying to get 100 guys out there in the middle of the bay with, traffic traveling next to you at all times, unless it was a nightly closure, was absolutely a challenge for us. So the latex-modified concrete specs, standard specification required a wet cure of 48 hours and an air cure for 72 hours, which is 426-0307. The wet cure shall be performed using wetted burlap and polyfilm. After 48 hours, remove the burlap and polyfilm to achieve an air cure. The latex shall not be placed at an ambient air temperature below 45 degrees. To cure the latex modified concrete at a minimum of 50 degrees. If the cure temperature falls below 50 degrees, extend the cure duration by the number of additional required cured days. So not being able to pour with temps below 45 degrees was lifted and revised to not placing latex if the air temps were not to be below 32 degrees within a 5-day cure window. So going back to the original contract and not being allowed to have the long-term lane closure, with this spec becomes very difficult for the standard spec for latex of when you can and can't place it. So it was kind of like the traveling public and the traffic was really what drove all the decisions for the MDTA on this, because their hands were tied. They're getting a lot of backlash, so they had to more or less bend these rules to make this project possible. So the MDTA allowed Wagman to take temporary lane closures during the daytime, which was not previously allowed. As you can see here, we're out here daytime. We actually did a fair amount of daytime lane closures to place latex. And on a normal night shift, we might be placing, say, 300-400 feet. Daytime closures, we might only get like 120 foot in a 4-hour window. So it kind of was advancing us little bit by little bit, just to get more or less something done rather than waiting for a more favorable window. As you can see here, so we actually have some heater hose. Ground heaters were a big thing for us. That wasn't necessarily something that was a part of any Maryland standard specification, but considering trying to place this latex through the winter, this was necessary to achieve the specifications for cure temperatures. So we have our polyfilm right here. Underneath would be, winter blankets. Sometimes it would be a combination of burlap, heater hose, concrete blankets, poly, trying to keep the air out. As you see in the lower left here, so we have a 4-inch supply hose. We actually stretched this a couple miles. I want to say we had like 4 or 5 miles of 4-inch hose that stretched back to the eastern shore, and that was what was servicing the water for the hydro demolition, whether that was clean water going to the robot or if we were taking the dirty water from the operation and pumping it back to the eastern shore to be contained and dealt with. So lots and lots of hose strapped to the side of the bridge rails. So trucks were mobilized on the bridge each shift and staged in adjacent temporary lane closures to pour from the closed lane. So again, this is another daytime operation. We have our barrier wall, our work zone. This would, under normal circumstances, this would be open to traffic. Daytime, they would have 2 lanes of traffic. We would have these 4-hour closures. Traffic would be in the far lane, and we would be occupying this lane so we could pour over here. Some of the challenges, again, significant deterioration in localized areas. As you can see here, I mean, that's water to the bay below. This was a patch, so you have an existing concrete that you're dialed in on your robot, everything's good. You hit this patch and it's not taking a lot because the patch is stronger than the existing deck, so you're monitoring it and everything's going okay. You're like, oh, that's pretty hard, and then boom, straight into the bay. So we had a lot of issues with that, but again, tons and tons of monitoring to, not have that issue. We did have some smaller localized areas that, we had to do a full depth repair on. Some of those were maybe 60 foot long. So, full deck replacement in these sections was not expected, but, the deteriorated deck just kind of resembled Swiss cheese out there. Access, same as the Nice Bridge, very difficult access. Wind, weather, receiving lane closures. I will say the weather at the Bay Bridge definitely has its own microclimate. We noticed that the temperature of the water really played into, the season. If it was late fall or early spring, was the water warm because of summer going into fall? That helped us. In the spring, water was super cold from the winter, so that hurt you, even though if you were on the eastern shore in Kent Island, temperatures, if you were placing in Kent Island, would be favorable. Up on the deck, you're 150 foot off the water, very different, could be a 10-degree difference, which would be the difference between us placing or not. So very challenging with the weather. Also wind, same as the Nice Bridge had commented. Wind up there, very different. You could be down at ground level, eastern, western shore, might be 5 miles an hour. You get up top and it could be 30 miles an hour. They wouldn't allow you to have lane closures. Extremely, extremely difficult place to work. Some high-level facts here from the project. So we used 2.2 million gallons of water. That's strictly fresh water servicing the robot for the hydro demolition. So it takes an incredible amount of water for that process. 26,000 feet of lay flat hose. We had about 15,000 feet of temporary barrier wall out there. We replaced 860 foot of expansion joints. We placed just over 1,500 cubic yards of latex-modified concrete. So the average depth of the pours was 3.5 inches, but the interesting part was the average thickness of the deck from one end to the other. It could vary slightly, but 6.5 inches, 7 inches. So our average was taking out half of the deck, which is kind of scary once you come to that realization and you're up there over the water. But that just kind of proves how deteriorated that deck really was, especially with the intent that it was really just supposed to be a 2-inch overlay. We had quite a few ground heaters out there to make this possible. Tons and tons of concrete blankets, and again, we did silane sealant on the entire bridge deck when we were done. This is a picture of our final pour. This was, a huge accomplishment for the guys, for everyone involved. It was like, so thankful that it was like kind of finally over with. But a quote here from Governor Hogan: "The project was envisioned as taking 2 construction seasons to complete, but our dedicated employees and contractors working to serve their neighbors and all those who use this bridge have completed it in just over 7 months, record time by any measure." Governor Hogan added that the men and women who have accomplished this task inspire me and will forever have my appreciation. So, really cool to be a part of this, but any hair loss I have is absolutely from this project. Here's a short movie MDTA had put on for this. That's all I have, guys, if you got any questions.